In this final section, I'm going to cover a range of cognitive tasks which, like the dichotic listening phenomena I covered earlier, seem to occur outside of consciousness. Earlier I pointed out that the moment at which a decision is made is generally outside of consciousness, although there may have been a lengthy stream of consciousness that explored different alternatives. So let's have a look at why. The stream of consciousness is this process by which the population of active receptive fields is evolved on the basis of different combinations of indirect activations, with the objective of achieving a population with the most appropriate predominant recommendation strengths. At each point, active receptive fields have recommendation strengths into the basal ganglia, including speech recommendation strengths that can generate descriptions of the current population. The moment of decision is the point at which there's a predominant recommendation strength across the latest population in favor of one of the alternatives being considered, plus sufficient recommendation strength in favor of rewards that the selection is locked in, meaning that it will become the predominant recommendation of any population activated in similar circumstances in the future. The critical decision-making activity is therefore in the basal ganglia, and the processes in the basal ganglia don't result in receptive field detections that could recommend speech behaviors. Hence, the moment of decision-making can't be described in detail verbally. Another example I mentioned earlier is driving a familiar route, where sometimes at the end of the journey we've got no memory of actually travelling the route, generally because our thoughts have been elsewhere. So what's going on here? Once again, let's use this model, and at any point on the journey, receptive fields are detected within visual and somatosensory inputs. These combine to generate receptive fields in the motor cortex, and these detections recommend appropriate movements to control the car. If there's very little novelty in the experience, there are few receptive field expansions required anywhere in the cortex to generate the motor cortex detections. So there's no hooks to make it possible to recall the experience. While you're driving, there may be indirectly activated populations corresponding with the stream of consciousness that I've illustrated by the pink population. There may be more novelty in this stream of consciousness than in the activations that control driving. So we may be able to recall what we were thinking about better than our driving. There's also the phenomenon that self-awareness can interfere with the practice of a complex physical skill like archery. If we have such a skill, receptive fields detected within visual and somatosensory inputs drive motor cortex receptive field detections, perhaps through intermediate areas, as illustrated by the red column population. The specific motor cortex receptive fields have very closely adjusted recommendation strengths in favor of exactly the appropriate skill behaviors, the muscle movements to control the bow. But if indirect self or stream of consciousness populations are activated, such as the pink population, those pink columns may lead to some different motor cortex detections, and those slightly different receptive fields may have predominant recommendation strengths a little off from the most skilled behaviors, which will deteriorate performance of precise muscle control. So what we've done in this section is to establish a way to describe some of the key phenomena we think of as human consciousness. The stream of consciousness, self-awareness. We've described these phenomena in terms of sequences of high-level information processes, one process driving the next, using processes that are to significant degrees approximate, but that we know how to map to more and more accurate descriptions through anatomy, physiology, all the way down to chemistry. And in the end, that's what understanding a complex system means.